Hey all, thanks for joining me. I'm going to be making a video on the entire process for CNC machining or routing. And the process starts with the CAD, then the CAM, and the control. The CAD, which we create all of the geometry, the primitive geometry. And the CAM is where we apply the machining operations to the primitive geometry, and then we actually cut it out on the CNC machine. So in this case, I'm working on a floor system. I've already designed this, and it's a floor tile system where I can actually store things underneath the tile. I gave myself a little bit of room here to pick up the tile, so it's not hugging so tight. But that's actually part of the problem, because I want to be able to make it so when I lay down the tile, it actually shows these seams nice and evenly when it's laid. It's not really too big of a deal for me, but it would be nice to at least have some kind of aesthetics when it's laid down. So what I'm going to do is I'm going to create a cross or a plus here. This is about 1 inch and 1.1 inches, because this kerf here is 0.1 inches. So let's go ahead and do that. But I'm going to show this design in 3 different ways. One from the CAD program, like AutoCAD. Another way would be from this program here. And then another way would be through my CAM program, because my CAM program has a little bit of CAD abilities, I guess. So you can create geometry, primitive geometry in CAM. I'm going to start out with the CAM side. So I'm going to get rid of this. I already know this is 1.1 inches here. So I would like to make something so it actually catches on to the corner here, so it maintains its position. But in this one, I don't want to make it too complicated, because a lot of my customers and users, I want to start them off with a very simple design. So let's go with just the plus. And let me just check. This is going to be about 1.1, 1.1. So I shouldn't have to make something very large. So let's go ahead and start my CAM program. Okay, this is the CAM program that I use. It's called CAMBAM Plus. This is the Pro version. Very, very inexpensive, and it's essentially just a 2D design surface. You can also look at the 3D part of it, but it's very minimal. It really just goes through or shows you a wireframe version of what you're doing, and also shows you the toolpaths, which is really convenient. So in this, I'm not going to go through the whole user interface. Through time, if you keep watching my videos, you'll probably get enough of this to know what's going on. Right here is the CAD icons or functions, and these are the primitive geometry, like line, polyline, circle, arc, things like that. And these are the machining operations, or what is typically in a CAM program. So what I'm trying to create is essentially a plus sign. So I'm going to use a rectangle. I'm going to just draw a couple of rectangles. It doesn't really matter. I'm making them arbitrary because I'm going to change the dimensions here. So let's see. I'm going to drag this across. So this particular rectangle width is 11 and the height is 3.125. But I know that I want this to be 1.1. And I want this one to be 1.1. So the height and the width is 1.1. Okay. 1.1. All right, so let's make the height of these, let's say 3. It doesn't really need to be that large. Let's do the same thing to this one. Make it 3. Now what I want to do is I want to move them. I can use the shift key to move. It doesn't, for this particular example, it doesn't really need to be centered or anything. I'm going to center them in a moment. But as long as they have some kind of a plus. Let's see if I can make this centered here. Looks like I can specify the lower left. Let's go ahead and make it 1.5 because 1.5 is half of 3. And let's do the same thing with this. Look at that. Okay, so I'm going to move all of this to the far corner. So I like to make it as close to the origin as possible so I can, on the CNC machine, I know where I'm actually going to be machining. Okay, so I don't need these lines here, so I'm going to remove these lines. And in this particular CAM program, it's not as intuitive, so I'm going to break at intersections because these have intersections here, like these where they cross. I'm going to break at those intersections under the edit menu. And I'm just pressing the right button to get to this edit menu. Break at intersections, and then it gives me a little dialog. What's the tolerance? I'm just going to put 0.001. It's going to find its location since this is a very simple set of geometry. So now you can see that it broke it. I'm going to delete those using the delete button, and now I have that that plus sign. So I'm going to select all of it, and let's see what I'm going to do. Oh, I'm going to join all of the lines to make a polyline. So my join tolerance is going to be 0.01. Since, like I said, it's not very complex, it's going to get right at those locations. If it was a little bit off, then it would. If it was less than 0.01, then it would join those two. Okay, so now if I select it, it'll be one continuous polyline, and it should be closed. Closed is equal to true. So I have my primitive geometry. I have a lot of lines that is actually connected into polylines, and that would be considered primitive geometry. Now I need to cut this out. And I want to cut this out on the outside of these lines, outside of the polygon. So I'm going to use the profile machining operation. And I have this selected. So if it's selected, I can go ahead and press the profile. And I usually do two profiles because I want one as a roughing and one as a finishing. There's one thing I forgot to do though. I did the profiles, but I didn't set up my stock. And this is generally something that I need to do to specify essentially the depth of how far it's going to be, how deep it's going to be milling, or how deep or how thick the material is. So the stock size is going to be, let's see, this is 1, 2, 3, 4. It's about 4 by 4. And then the depth is, I usually put 0.81 if it's a 3/4 of an inch. Because I like it to go a little bit farther down, and it uses the stock to determine its target depth. So if I press Control T, which is actually the same thing as, let me put this in because since I changed this, it's asking me should I change the existing value from 0 to negative 0.81. So yes, I do, and you can see that it's a really small object. So let's see, machining, generate toolpaths is Control T. So I'm generating the cut toolpaths. And you notice that the profile 1 and profile 2 is actually created on the left-hand side. This is the outline. And each one has its own parameters. And the parameters are actually quite complex, but once you set your CAM styles, you don't really have to worry about a lot of these parameters, but you have to start somewhere. So you have to set up those styles in the beginning, and you can probably use this for any specification for parameters that you need to use. Just look at all the parameters here and see what I'm using. I'll go over most of these parameters over time, but in this particular one, I want to point out a few of them, and one of them is the holding tabs. So I have 4 holding tabs here. I want to make sure that these holding tabs are going to hold the part in place after it's finished its entire process of milling. The first profile I want it to be roughing. I already created a style called roughing. Okay, so you can see the A roughing here under the CAM styles, standard inches. And this generally is derived from this particular style, which has no name, and this is the default style. So when you do a profile without making any style, that's what it's going to give you. It's the default. And then the roughing will derive from that default style. You can also create a parent style if you want. So I could say this roughing derives from any of these other styles. So it'll just modify from that particular style. All right, so this is a roughing, and then this is a standard style. And the standard default I made as a finishing. So I'm going to press Control T again, and you'll see that two lines appear here. And that shows the roughing is on the outside because it leaves a little tiny bit of material, and then the finishing comes along and does it to the specified dimension. So the finishing will finish it at 1.1 inches width here and 3 inches from here to here. The roughing, I'll show you what the roughing has. Let's see. The roughing clearance is 0.005. So I leave 0.005 of material there. It actually may be a little bit more or a little bit less than that, depending on the load on the machine against the material and which direction the spindle is spinning the end mill, because it will pull into the material or it will push out of the material depending on if it's a climbing or conventional. And these things, this terminology I'll explain in later videos. So, but don't worry about it right now. Okay, so this is completed. I generally check it by using the Alt button and scrolling up, and I can see the machining operations. And in the roughing, I have it going through 2 passes. I could do it as a single pass, but I generally like it to go and do 2 passes. And I'm still working with understanding the differences between the two. I haven't done enough testing to see what differences they'll have if I do a full pass, if I'm getting dimensional accuracy out of a single pass. But 2 passes, because I'm not going so far down, I am actually not putting as much load on the end mill as I would if I was going full depth. Okay, so let's go ahead, and I'm going to save this as, let's just call this the, okay, so I'll call this the spacer between tiles. Actually, you can't see that, can you? I called it spacer between tiles. So let's go ahead and save that. It's going to be saving as a CB file, which is a CAMBAM file. And then that's not the file that will be going into the CNC control program. What I need to do is produce a G-code. So when I produce G-code, it'll create a file, space between tiles.nc, and that is an NC is a file that has the G-code inside of the file. I can actually show you what that is. Let's go ahead and save that. I'm going to use a program called Brackets, which is by Adobe. I like it. Let's see. Let's make it smaller so you can see it. Okay, so this is what G-code looks like. Generally, what this does is like this one right here. It specifies location and intended speeds and feeds. The G0 is a rapid movement, and a G1 is a movement under a speed and feed. And you can see that the F is there. This is the feed rate. I have it at 40 inches per minute. I like to use 40 inches per minute for my Z axis. And specifically, this is because it's 40, it's actually going into a profile at a slanted way. So it's actually going to be a little bit slower than it would be doing a normal plunge. And then it goes 100. The feed rate is 100, and it actually goes down and goes across. You can see it's specifying a Y location, and it's going to go down to that particular depth. Then it specifies another Y location, and it goes down to another depth. And and I also forgot to show you another thing here. Let's see. You will also notice a little tiny line here in the corners, and that is actually a corner overcut. Yeah, corner overcut is equal to true. If I put false here, then it wouldn't put a little line here. What that does is it allows something else to be flush to the corner here. Otherwise, it would have created a little curve with the radius of the end mill. And that would not allow something with a right angle to be flush into this location. So I wanted to make sure that I had a corner overcut, so anything that would be placed in this corner would be flush. You can see these are very sharp corners here. This one, and these two. And if I didn't have the corner overcut on that piece that I'm creating, then this wouldn't actually fit because it would cut into this corner. So let's get back to the CAMBAM. So now I am ready to run it on the machine. I don't need to make any changes to the location of the holding tabs. I like the positions. And let's see, just to make sure everything looks good. This is a pretty simple one. So I'm going to go ahead and save it. I've already done that actually, haven't I? Produce G-code, override the existing file, sure. And I'm going to go ahead and run it on the machine. So I'm going to set up my wood and start the process. Okay, I'm going to open up the file that I just made. And this is Mach3, floor storage tile, and it should be if I do date modified, yeah, spacer between tiles. And we should see it here. It's a little small. It's because my machine actually isn't in the right location. You can see that I set up some wood here. A little scrap piece should be large enough. So I'm going to turn on the machine and move it back. Alright. I'm going to do a ref all home. Okay, the only thing I need to do is set the Z to 0. Looks like it's about time for me to surface my spoil board. Okay, I'm going to lower the Z until it gets to the surface of the material. Okay, it is at the surface of the material. I know that all three are now at 0. I can go ahead and press 0Z, so I know that's at 0. The top of the surface, or the surface of the material, is my 0, and anything below the surface of the material is going to be in the negative region. So and I just press a regen toolpath because my tool is located right here, and I'm able to see this in a larger way. I'm going to bring up the Z a little bit using the page up. So when I start the spindle, it won't mar the material. When I press cycle start, it'll start to move and cut out the material. So let's watch that happen. So this is how the part looks like before I remove it from the wood. You can see that there's still a little bit of fuzz here. That's normal since this is an upcut bit, so it's cutting in upward direction, and you're going to get a little bit of fuzz here, but this is actually really easy to remove. So you can get it to be a pretty sharp corner here, and you can also see the corner overcuts. See, so it goes a little bit farther in to the material, and it allows something that would be at a right angle to fit into this location. So let me cut that out and prepare this so I can actually use it. You can see where the holding tabs are. You have to be really careful when you cut these off, because it can start to cut into the material, and it's kind of bad when if you're delivering something to a customer. It's going to be really hard to maintain a good surface. Well, in most material, this is MDO, this is a medium density overlay. So there's a little thin bit of material here that can sort of flake off. And this is actually the protective material that is used for construction that makes it somewhat water resistant when it's used for concrete forming. So in this particular case, I don't actually need to cut this off. I don't need to cut the holding tabs off, but I'm going to for this demonstration just to show you my process. But I'm going to be putting it into my floor tile, so this is actually never going to be seen. So I don't actually need to cut these off. And so let me show you my way of removing these holding tabs. I use a really simple process where I have a bearing and a 1/4 inch router bit, just connected to just a wood surface. I mean, it's nothing fancy here. I also use a device like this for smaller parts. Let me see if I can zoom out here. Yeah, for smaller parts, so I don't get my hands in the way, because this is pretty sharp, and if my finger went into this, it would be pretty catastrophic for my finger. So I need to adjust the height of this so the bearing can ride along the smooth surface. That looks good. Okay, and I'm going to go ahead and turn it on, and I'll first put it into this vise here. Okay, and we'll turn it on. You can see the vise wasn't perfect. It slipped a little bit because it's trying to hold on to very small amounts of material, the holding tabs. So now there's no holding tab here. You can see how smooth that is. It's pretty good. Okay, so all sides look good. They're flat. All the holding tabs are gone. So I'll put it into my flooring system and see how it works. Okay, I need it in all of the other sides so it can be evenly spaced, but it looks pretty good here. I mean, I can see that these at least are aligned, where the other ones are pretty much off alignment. So I'll probably make a few more. Maybe I'll make some enhancements to the design, but that is how to go through the process of designing something from CAD, CAM, and CNC control. And my next video will be using AutoCAD as the method of CAD, and then I'll pass that into the CAM and then the control. Thanks for watching.